Alright, now the test for the stretch reflex of the bicep muscle is flexing of the arm and tapping the bicep tendon with a patellar hammer. Alright, this is how we test for stretch reflex of the bicep muscle in the laboratory. Okay, fantastic. Now the stimulus here is actually stretch of the biceps muscle. So when the biceps muscle is stretched, that stretching of the biceps muscle represents the stimulus. Okay, fantastic. Now the sense organ or the receptor for the stretch reflex of the biceps muscle is the muscle spindle. All right, a diagram here shows us the muscle spindle. Okay, this is the muscle spindle. All right, and it represents the sense organ or the receptor of the stretch reflex of the biceps muscle. All right, going forward. Now the afferent nerve fibers are the IA and the II group of nerve fiber. All right, these blue nerve fibers here represents the afferent neuron. The afferent neuron is also known as the sensory neuron. So the afferent neuron for the stretch reflex of biceps muscle are the IE and the II group of nerve fibers. All right, this one here. Good. Going forward, the center is formed by the spinal cord. So the center for the stretch reflex of the biceps muscle is the spinal cord. All right, Jessica's spinal cord. Good. Now the efferent neurons are the alpha and the gamma motor neurons. Good. This neuron here represents the alpha motor neuron. All right, it is written down here, alpha motor neuron. Okay, whereas this one here represents the gamma motor neuron. All right, both the alpha and the gamma motor neuron constitutes the efferent neuron of the stretch reflex of the biceps muscle. Hope that is clear. Fantastic. Now the effectors here are the biceps muscle and the triceps muscle. The bicep muscle is the one in front of your arm, while the triceps is the one behind your arm. All right, I hope you did that in your anatomy. Good. Now the response of the stretch reflex of the biceps muscle is contraction of the biceps muscle. This muscle here contracts while the one behind relaxes. So the response are contraction of biceps muscles and relaxation of the triceps muscle. All right, fantastic. Now when Jessica's bicep muscles are stretched, all right, the sense organs, which are the muscle spindles, are stimulated. Okay, the stimulation or activation of the muscle spindles would cause activation of the afferent neurons, which are the IA and the II group of nerve fibers. All right, the afferent neurons now carries this information to the integrating center. The integrating center here represents the spinal cord. Okay, the integrating center processes this information and then sends down motor commands through the efferent neurons, which are the alpha and the gamma motor neurons. All right, these efferent neurons carries the motor command back to the effector organ, that is back to the muscles. Okay, good. When the information gets back to the muscles, it causes a response, which are contraction of the bicep muscles and relaxation of the triceps muscle. When the muscle contracts, it is prevented from being further stretched. Now, this inhibition of the biceps muscle from further stretch prevents the bicep muscles from being damaged or torn. Okay, good. That is the essence of all of this. All right, good. There is what is known as reciprocal innervation.